towards heart disease prediction using hybrid data mining. Firstly, what is data mining? Data mining is the task of discovering interesting patterns from a large amount of data. It is used to analyze the rich collection of data from different perspectives and drive useful information. It is also known as knowledge discovery in databases. Next is confluence of multiple disciplines, in which we use database technology, statistics, visualization, machine learning, information science, and other disciplines to form a data mining. Medical data mining involves a lot of accuracy and uncertainty. Quality service at affordable cost is also a major challenge in this mine. Data is also massive in this case of mine. Decision based on doctors' experience may fail in some cases. Data mining in healthcare is an intelligent diagnostic tool. In 2015, an estimated 17.7 million people died from heart disease. Heart disease is the major cause of death in many countries. Heart disease is basically the disease and the conditions affecting the heart. The heart consists of muscle that pumps blood, arteries that supply blood to the heart muscle, and valves which ensures that the blood within the heart is pumped in the correct direction. Problem can arise in any of these areas like cardiovascular disease. Heart disease is a term that's somewhat loose and broad. It's often used that way. Heart disease is an umbrella term for a number of diseases which affects heart. The most common heart diseases are coronary heart disease, carotid artery disease, peripheral artery disease, chronic kidney disease, heart failure, cardiovascular disease. This is the description of a dataset in which we have used of various attributes, and description of that attributes and possible values are shown. The dataset mainly collected from the University of California, Alpine. This dataset is a combination of Cleveland dataset, Hungary dataset, Switzerland dataset, Long Beach dataset, and Statler dataset. Dataset mainly consists of 76 attributes. In our present work, we have used only 14 attributes. Data mining techniques in heart disease prediction consists of classification, bagging, boosting, hybrid classifier with weighted voting. Classification based on supervised machine learning algorithm is a collection of records or a training set. Each record contains a set of attributes. One of the attributes is the class. Find a model for each class attribute as a function of the values of other attributes. The main goal of the classification is to assign a class to a previously unseen records as accurately as possible. The given dataset is divided into a training and testing dataset, with training dataset used to build the model and testing dataset used to validate it. Bagging creates samples by repeatedly randomly resampling the training data. Given a training set of size n, create m sample of size n by drawing n samples from the original data with replacement. Each bootstrap sample below average contains 63.2% of the unique training samples, and the rest were not replicates. Combine that m resulting modules using weighted pool and decrease the error by decreasing the variance in the result due to some unstable learners algorithm whose output can change dramatically when the training data is slightly changed. This is the framework of a bagging in which we divide up a dataset into a training and testing dataset. From that training dataset, we divide up dataset into three samples, like we have a sample 1, sample 2 and sample 3. An SVM model is applied to each sample and the results are combined and test a model using a testing dataset to obtain the final accuracy. Boosting is revised to be a practical algorithm ADA boost for building a sample set empirically improve generalization performance. Boosting is also used to convert a weak learning algorithm into a strong one. The main idea behind the boosting is to combine many weak classifiers to produce a powerful committee. In the early iteration, boosting is primarily a bias reducing method. In later iteration, it appears to be primarily a variance reducing method. This is the boosting framework in which we have used some ranking strategy to obtain the final result. Next is hybrid classifier with weighted weighting. This classifier contains 9 classifiers which are employed to generate and assemble. The 9 classifiers that we have used are sport vector machine, neural network, decision tree, generalized linear model, lesser Bayesian regularized neural network, classification and regression tree, multivariate adaptive regression supplying sulfur cold as earth, and C tree. Their accuracy is calculated by testing each model on the test dataset. Models so generated are arranged according to their accuracy in ascending order. Models with the least accuracy are combined for the assembly to give the combination result 1 which has accuracy better than the model so used on the basis of weighting voting. Similarly, the combination result 2 and combination result 3 are also found. These combinations are then assembled to predict the final output which is hence the final output for the HCWV. Output of HCWV is tested against the test dataset and has the accuracy greater than the accuracy of all the models used. This is the proposed framework for the HCWV. Next is result. Machine learning procedures are used to retrieve the hidden knowledge that can be used for good decision making. This study has made the comparison amongst two normal classifiers which are linear model and SVM. Two models which incorporate embedding using GLM, SVM, two models with the use of boosting approach namely XGB linear and GAM. The proposed hybrid approach HPWP on the basis of accuracy for hard disease dataset. Performance of several models has to be equated with each other to recognize the correctness of model to a particular problem. Next is performance is analyzed on the basis of first we have accuracy. Accuracy is one way of arbitrating the performance of a classifier. Here is shown for the formula of classification based on the accuracy. Here TP represents total number of correct positive classifier and TN represents the total number of correct negative classifiers. Next is sensitivity or recall. It is defined as the number of true positive over the number of true positive and the number of false negative. Next is specificity. It is defined as the ratio of number of true negative to the sum of number of true negatives and number of false positive. Here it shows the comparison of HCWV accuracy amongst all the classifiers, which shows that the highest classification is shown by HCWV, which is 82.54%. This is the comparison model of all the classifiers, which shows that HCWV has the highest classification accuracy. Next is comparison on the basis of sensitivity, which shows the sensitivity of HCWV is 0.97, which is the highest among all the classifiers. This is the comparison study for the sensitivity of classifiers, out of which HCWV shows the good result. This is the specificity HCWV classifier, which shows that it shows a higher specificity of 0.82. Similarly, this is a comparison study for the HCWV classifier on the basis of specificity. Next is conclusion. Using hybrid data mining methods demonstrated favorable outcomes in finding heart disease. In the current work, we have successfully achieved higher accuracy by using hybrid data mining for heart disease analysis. Estimates made by the hybrid framework will be helpful in healthcare in making reliable diagnostics. Thank you.